I really love my coffee machine, but compared to the newer stuff that's coming out these days, it's just feeling so dated. There's nothing I can program, there's no screen to tell me what's going on, it doesn't have PID control for better boiler management, and I can't measure the espresso shots, I have to use a scale. But the new machines, they're so expensive, can't afford one. If only there was like a programmable controller I could fit to my current machine that adds new fancy features and settings that I can program. Someone should really invent that. If you're still using the old, outdated factory controller in your espresso machine, it might be time for an upgrade. Introducing Smart Coffee, the ultimate replacement that brings modern technology to your beloved coffee machine. Smart Coffee isn't just a replacement, it's a transformation, with PID control for precise temperature management, gravimetric espresso shots using a load cell for perfect consistency, and compatibility with both single and dual boiler machines. Smart Coffee redefines what your espresso machine can do. It even includes an ultrasonic sensor to monitor water levels, a customizable pre-infusion cycle, and 2 temperature sensors. All this information is right at your fingertips on an OLED display, which can be panel mounted or adapted to replace the pressure gauge. Upgrade your espresso machine experience with Smart Coffee and bring your machine into the future. You can purchase the complete Smart Coffee kit directly from my website. The kit includes everything you need to get started: the Smart Coffee board, 2 ESP32 modules, and a sleek OLED display kit with a custom mount. We've also included our Smart Coffee software, a comprehensive wiring guide, and a step-by-step programming guide to make installation easy. From here you can build up your kit by choosing what sensors you'd like to add to your machine. With Smart Coffee, the possibilities are endless. Get your kit today and start transforming your espresso experience. So with all that said, how can you get your hands on the new Smart Coffee circuit board? Well, at the time of publishing this video, kits are available on my website. There is a limited supply of kits available, so if they sell out quickly, don't worry, because you will be able to secure yourself a kit by pre-ordering a kit for the next shipment. With all that said, let me show you how I fitted the new Smart Coffee project to my espresso machine here after this short message from this video sponsor. JLC PCB have not only sponsored this video, but also manufacture the Smart Coffee circuit boards used in this video. JLC delivers the boards with all the fiddly surface mount components pre-installed and ready to go right out of the box. When a new shipment arrives, all I have to do is hand solder the larger components and another Smart Coffee circuit board is ready to be shipped out. Ordering custom circuit boards from JLC is simple. Head over to their website using the link in the description and upload your Gerber files. You'll be able to see the manufacturing cost and view your design on their website. You can also customize the design parameters and choose any color you want. Blue is my personal favorite. Thanks to JLC PCB for helping make Smart Coffee available. Using the brew lever activates the pump like any other E61 machine. However, with Espresso mode activated, the machine performs a customizable pre-infusion cycle, followed by running the pump until the programmed amount of coffee is produced. In my particular setup, I've mounted a scale in the drip tray to weigh the amount of coffee. When the brew switch is activated, the scale is reset to 0 to weigh only the espresso poured into the cup. The pump is then automatically turned off to produce the same amount of coffee every time. Smart Coffee is designed to be highly customizable to be compatible with a wide variety of machines. Pause the video here if you'd like to read some of the features that are available. Depending on what sensors you've opted to use, there are two different display layouts for single and dual boiler machines. Now let's look at the hardware on the circuit board. Here we have the AC power input, which powers an onboard 5-volt power supply to run all the electronics. Over here we have 5 onboard solid-state relays to control elements, pump, valves, and pretty much anything else you'd want to control. Plus, you can also connect an external relay to one of the 5-volt relay control outputs to switch high current loads. Over here is a load cell amplifier, which gives you the option to dispense espresso shots by measuring the weight of espresso dispensed into the cup. Alternatively, you can use a flow meter to dispense espresso shots by volume, or a timer to dispense shots by time. We also have 2 thermocouple amplifiers that are compatible with 2, 3, or 4 wire temperature probes. These can be used to measure the boiler water temperature or any other temperature on the machine. And of course the board has inputs for boiler water probes, switches, and so on. The brains of the operation is an ESP32, which plugs into the socket on the board. And what's better than one ESP32? That's right, 2 ESP32s. Why 2, you ask? Well, one ESP doesn't have enough pins to run everything on the board. So the second ESP32 is programmed to be what I'm calling an intelligent I/O expander. Essentially its job is to take various readings from the sensors, make calculations, and then send the data to the main ESP32 using UART communication. The benefits are twofold by increasing the number of I/O pins available for the project and doubling the CPU processing power. That's the hardware covered, so now let's have an overview of the software and programming. Programming Smart Coffee can be done on a PC by opening the code in programs such as Arduino IDE. You can customize what features you'd like, such as pre-infusion, espresso shot weight, volume or timer, pressure and temperature safety limits, configure when each relay is turned on or off, program PID or PWM logic to control boiler pressure or temperature, and much more. Plus, you can send commands via serial input to enable or disable features or update any value while the machine is running. This allows the user to quickly adjust the settings on the fly to dial in that perfect cup of coffee. For some sensors, calibration is necessary to achieve accurate results. Fortunately, there is a calibration wizard which guides you through the calibration process for several sensors, which means all you have to do is follow the instructions provided by the calibration wizard. Currently, my machine is fitted with the old Arduino Mega version of Smart Coffee, but I'll be removing most of the hardware from my previous build to fit the new version. Each coffee machine will be different, but this video should contain enough information to give you an overview of the conversion process. I'll start by removing the panels to gain access to the hardware inside. Here is the old Arduino Mega that I was using to run the machine. The enclosure, Arduino and temp sensor are all being replaced so they can be removed to make room for the new circuit board. The external 5-volt power supply and relays are also made redundant by the new circuit board so they can be removed from my machine. On the topic of flow meters, the new version of Smart Coffee is compatible with volumetric espresso shots using a flow meter. However, I'll be replacing the flow meters for a load cell in the drip tray. The load cell I'm using is rated for up to 1 kilo and will be mounted in the drip tray. To connect the load cell to the chassis of my machine, I'll be using this 4 pogo pin magnetic connector. First, I cut a hole in the drip tray to mount one side of the connector. Then I scribed a mark on the chassis so the mounting holes are perfectly aligned. To mount the load cell, I machined a small mounting block that raises it up from the bottom of the drip tray. Silicon sealant was applied to the underside of the mounting block to prevent water from leaking through the mounting holes. I then 3D printed a grate to place the cups on. However, this is only a temporary solution because later I'll machine one from metal. Lastly, I used black polyurethane sealant to protect the wire connections and mounted the connector to the drip tray. With that done, the load cell installation is complete. Next, I installed the M3 brass standoffs onto the PCB mounting holes. Screws are then used to mount the PCB to the coffee machine. There is a wiring guide which explains in detail how to connect the various sensors, relays, and power in and out from the circuit board. You can find this on my website by following the links in the video's description. First, I can begin by connecting live, neutral, and earth to the circuit board. Then I connect the solid-state relay live outputs to my pump, element, and solenoid valve. I'll be using the same thread adapter and pressure transducer that I used from my previous build to measure the boiler pressure. Then it's just a matter of connecting the brew lever switch, boiler water level probe, and other sensors I've opted to use on my machine to the circuit board. Now about mounting the OLED display. I have two options. The first option is a panel mount display kit, and the second option is a pressure gauge adapter kit. First, let's consider the installation of the panel mount kit. I start by installing the screen and acrylic panel to the mount. This kit allows me to mount the display anywhere on the front of my machine by drilling 5 holes. Included with the kit is a hole template, and after drilling the holes, the display assembly is screwed to the chassis. However, you can avoid drilling holes in your chassis by replacing your pressure gauge with the display using the gauge adapter display mounting kit. First, I installed the OLED display and assembled the housing. Next, I can remove the factory pressure gauge and install the display in its place. You can buy both display mounting kits on my website. Alternatively, you can also download the STL files and 3D print your own. At this point the hardware is installed, but before I reassemble the side panels of the machine, I need access to the USB port of the master ESP32. So at this stage you should upload the software and calibrate the software before reinstalling the side panels. However, in my situation, this machine will be used as a testing platform for future updates. So I'll install two USB-C panel mount headers so I can connect to both ESP32s whenever I need to for future use. Now at this point I can start programming the default values in the code. Inside my programming guide, you'll find step-by-step instructions on how to open, program and upload the code to the ESP32s. But here's a quick rundown of how the process looks. Click on the config.h tab, which contains all the user programmable settings. All the settings and features have a brief comment next to them. If you need more information about a specific setting, you can look up that setting in the programming guide. To enable a feature, I can write true next to it, or to disable a feature, I can write false next to it. Since I'm using a pressure transducer for boiler 1, I'll program my min and max signal voltages along with the pressure rating. Next, I'll set my target boiler pressure at 110 kPa. Then I'll enable temperature sensor 1 safety limits and program my minimum and maximum temperature limits. Now I will enable the Espresso shot target as weight, and then enable the load cell and program my weight offset. Next, I'll enable the ultrasonic sensor and program the water level detection settings. Lastly, I can program the relays to turn on or off at various stages. However, for my machine, I can leave these at their default settings. At this stage I can upload the code to an ESP32. To avoid getting the ESP32s mixed up, you can write S for slave on one and M for master on the other. First I connect my PC to the master via USB. Next I select the USB connection in the drop-down menu. Under boards I select ESP32 dev module and choose my USB COM port, then press OK. Now I can compile and upload the code. With that done, I plug in the slave to my PC and open the slave program, and then upload the code. Now I can plug both ESP32s into the board. Make sure to plug the master into the socket labelled master and the slave into the socket labelled slave. At this stage, the coffee machine should be operational. However, before I can start making coffee, I need to calibrate the sensors. First, I'll loosen the compression ring on the boiler water probe. With my PC connected to the master, I open the serial monitor and then enter Calibrate B1 probe, which starts the calibration wizard for boiler probe 1. First, the calibration wizard asks me to lower the probe to the lowest position to determine if there is sufficient water inside the boiler. Then I reply with yes to proceed. The wizard takes a measurement of the probe and then prompts me to raise the probe up. Then I reply with yes to proceed. The wizard has not detected any change with the probe and asks me if I would like to refill the boiler, which I respond to with yes. Next, I set the probe at my desired fill height and type yes to start refilling. The pump will automatically stop when it detects water is touching the probe. Now that we have water inside the boiler, the wizard can now calibrate the probe. Next, I'm prompted to raise the probe to break contact with the water. The wizard automatically calculates the new B1 refill trigger value as 8. Before these settings are saved, the wizard wants us to verify the new setting is correctly triggering a refill. To do this, I lower the probe to make contact with the water. Then reply with yes. Then I raise the probe one last time and reply with yes. The calibration wizard confirmed that the calibration was successful and will now save and then reboot. The next sensor that requires calibration is the pressure transducer. To start the calibration wizard, I'll send the command calibrate PT1. During calibration, the wizard will take control of the boiler element relays. First, I'm prompted to enter my target pressure for boiler 1. For my machine, the value is 110 kPa. Next, the wizard needs to know the maximum pressure rating of the transducer. In my case, this value is 400 kPa. Now the wizard is asking me, if the boiler is pressurized, wait until the boiler cools down and there is no pressure. Since my boiler is cold, I can proceed, and the wizard measures the voltage signal at 0 kPa and uses this as a reference for later. Now we are asked for the maximum signal voltage, which in my example is 4.5. The wizard now turns on the boiler element relay. Now we have to wait several minutes until the pressure on the display is close to the target pressure I programmed earlier. With the pressure close to my target of 110 kPa, I can proceed by typing yes. Now the wizard asks me to use a separate and reliable pressure gauge to read the boiler pressure. Looking at the factory gauge on my machine, the pressure is about 1.07 bar, which converts to 107 kPa. The wizard now compares the pressure gauge reading I just entered and makes any adjustments if required. Now we're asked to let the pressure stabilize for a couple minutes using these newly calibrated settings. If we take a moment to compare the pressure on the display to the pressure shown on the gauge, we can see they are both reading 110 kPa now. The wizard is satisfied that the calibration has been successful and will now save and reboot. Now I can calibrate the load cell, which is by far the easiest sensor to calibrate. To start, I send the command calibrate load cell. First, I'm asked to remove all weight from the load cell. Currently there isn't anything on the load cell, so I can proceed by saying yes. Next, I'm asked to place a measured weight on the load cell that is at least 200 grams in weight. I'm using this 200 gram scale weight, and I'm placing it on my load cell. Next, I enter the weight in grams, which in this case is 200. And just like that, the load cell has been successfully calibrated. I can verify that the calibration has been successful by placing any amount of weight on the scale and comparing it to the value on the display. With that done, I can assemble the coffee machine and start making the best coffee it's ever produced. I plan on expanding the capabilities and features of Smart Coffee, so if you have any suggestions for features you'd like to see added in future updates, send me an email to mail@schematix.co.nz and check out the forum page for the latest information and updates on this project. If you'd like to learn more about the capabilities of Smart Coffee, programming information, or to order a kit, don't forget to check out the links down the video's description below to my website. Thank you for watching, and I'll see you in the next video. Bye for now.